Hello and welcome to Maths Exam Cruncher channel. In this video we are going to look at the compound interest formula and how to use it in exam questions. First of all, we are going to review the meaning of interest and compound interest. So what is interest? When you put your money into a bank, because you've let the bank to use your money, they will give you a reward. This reward is called interest. So for example, you put £100 into a savings account at the bank. The bank pays you interest for keeping your money with them. If the interest rate is 5% per annum, which means per year, at the end of the year, the bank will give you an extra £5 for your £100. So after 1 year, you now have £105 instead of £100. This £5 is the interest you earned. What is compound interest? Compound interest is calculated on the money you put in plus the interest it has already earned. For example, if you put £100 in the bank at a 5% interest rate, you get £5 in the first year. Then in the second year, you earn interest on £105. So you get £5.25. Let's see how we can answer exam questions on compound interest. In answering compound interest questions, we use the percentage multiplier. You can watch my video on percentage multiplier in percentage increase and decrease by clicking on the above link. Leanne invests £2,500 for 4 years in a savings account. She gets 3% per annum compound interest. How much money does Leanne have at the end of 4 years? We always say to ourselves that everything starts off at 100%. And we are earning 3% interest per annum. So we are going to add that on, which gives us 103%. And we must divide it by 100, which gives us 1.03, which is our multiplier. Then we write the initial amount, and then times it by the multiplier, raised to the power of number of years, which is 4 years. And that gives us £2,813, 77 pence. And that's the amount of money that Leanne will have at the end of 4 years. Annie invests £9,500 for 5 years in a savings account. She gets 1.8% per annum compound interest. How much money does Annie have at the end of 5 years? We know that everything starts off at 100%, and we are earning 1.8% interest per annum, so we're going to add that on. This gives us 101.8%, and we divide it by 100 to give us 1.018, which is our multiplier. And we write the initial amount, 9,500, and then times it by the multiplier, 1.018, raised to the power of number of years, which is 5 years. And this gives us 10,386 pounds 34 pence. So let's see how we can calculate the interest in compound interest questions. Perry invests £25,000 for 3 years in a savings account. She gets 2.7% per annum compound interest. Calculate the total amount of interest Perry will get after 3 years. So again, we start off with 100%, and we add the rate of interest, which is 2.7%. That gives us 102.7%, and in decimal after dividing by 100, it becomes 1.027. Then we write the initial amount, 25,000, and then times it by 1.027 raised to the power of number of years, which is 3 years, and that gives us 27,080 pounds 17 pence. So in order to find the interest, we have to subtract the initial amount from the final amount. So we write the final amount, 27,080 pounds 17 pence, take away 25,000, that gives us 2,080 pounds 17 pence, which is the interest. Matt wants to invest £8,000 for 3 years. He can choose between Bank A and Bank B. Bank A pays 1.2% compound interest per annum, and Bank B pays 2% compound interest in the first year and then 1% compound interest for each extra year. The question is asking which bank will give Matt the most interest after 3 years. We learned in the previous question that interest is equal to final amount minus initial amount. So we're going to find the final amount for both Bank A and Bank B. For Bank A, we start off at 100%, and since we're earning 1.2% interest, we add 1.2%. That gives us 101.2%, which in decimal is going to be 1.012. Then we write our initial amount, 8,000, and then times it by the multiplier 1.012 raised to the power of number of years, which is 3 years. And that gives us 8,291 pounds 47 pence. Then we find the interest for Bank A by writing 8,291 pounds 47 pence, which is the final amount, minus the initial amount, 8,000, which gives us 291 pounds 47 pence. That's the interest for Bank A. Then for Bank B, we do the same but in two parts, because first we have the investment for 1 year and then for the rest 2 years, making up 3 years. So we start off at 100%, and we are earning 2% interest. So we add 2%, so we get 102%, which will give us 1.02 for our multiplier for the first year. So we write the initial amount, 8,000, times it by the multiplier raised to the power of number of years, but that multiplier is going to be for only 1 year. So we just write 1.02. And that gives us 8,160 pounds. Now, the final amount for the first year is going to be the initial amount for the second year. So at the start of the second year, again, we start off at 100%, and we add the interest rate, which is 1%. That gives us 101%, and in decimal that becomes 1.01. So we mentioned that the initial amount at the start of the second year is 8,160, and then we times it by the multiplier 1.01 raised to the power of number of years. So we've used 1 year out of 3 years. There are 2 years left. So we write raised to the power of 2. And that gives us 8,324 pounds 2 pence. So that's the final amount after 3 years in Bank B. Now we work out the interest. So to do that, we write the final amount, 8,324 pounds 2 pence. Take away 8,000 pounds, which gives us 324 pounds 2 pence. So when we compare the interest in Bank A and Bank B, we notice that Bank B will give Matt the most interest after 3 years. So we write Bank B gives the most interest. After 3 years. Depreciation. Depreciation means that we are going to lose money as the years go on. Sharon pays £3,500 for a second-hand car. The annual rate of depreciation of the car is 24%. How much will it be worth 4 years after she's bought the car? So again, we start off at 100%. But because we are losing money, we are losing 24% of the value of the car, we have to subtract 24%. And that gives us 66%, which in decimal, after dividing by 100, it becomes 0.66, which is our multiplier for the depreciation. Then we write the initial amount, 3,500, and then times it by the multiplier, 0.66 raised to the power of number of years, which is 4 years. And that gives us 664 pounds 12 pence. So that means that the value of the car 4 years after it's been bought is 664 pounds 12 pence. And that's the final answer. Chow bought a boat for 160,000 Hong Kong dollars. The value of the boat depreciates by 4% each year. Work out the value of the boat at the end of 3 years and give your answer correct to the nearest Hong Kong dollars. Again, we start off at 100%. Since we are losing money by 4%, we have to subtract 4%, and that gives us 96%, which in decimal is going to be 0.96. Then we write the initial amount, 160,000, then times it by the multiplier raised to the power of number of years, which is 3 years. And that gives us 141,557 pounds 76 pence. But since we have to write the answer correct to the nearest Hong Kong dollars, so we write it down as 141,558 Hong Kong dollars. And that's the final answer. Let's work out the value of investment, which is the initial amount. X pound was invested for 7 years. It earned compound interest at 3.5% per year. After 7 years, the total value of the investment is £15,903.50. Work out the value of the investment, which is the initial amount of X pounds. Again, we start off at 100%. And since we are earning 3.5% interest, we add it on. That gives us 103.5%, and we divide it by 100 to give us 1.035, which is our multiplier. Then we write the initial amount, x, times it by the multiplier, 1.035, raised to the power of number of years, which is 7 years. And that gives us the final amount, which is £15,903.50. We've now formed our equation. In order to solve the equation, we need to divide both sides by 1.035 raised to the power 7. So we type that directly into our calculator, and that gives us x equals 12,500 pounds. And that's the final answer. Calculating the number of years. Fern invests £5,600 in a savings account. She gets 2% per annum compound interest. After n years, Fern has £6,061.62 in her account. Work out the value of n. Again, we start off at 100%, and we are earning 2% interest. We add it on. That gives us 102%, and we divide it by 100 to give us 1.02 for our multiplier. Then we write our initial amount, 5,600, and then times it by the multiplier, 1.02 to the power of number of years, which is n, and that gives us £6,061.62. Now, in order to find the number of years, we have to use the method of trial and error. I would normally start with replacing n with 5, and then I'll change the value of n if I need to. So I start by writing n equals 5. So say if n equals 5, then we write 5,600 times 1.02 to the power of 5, and that gives us £6,182.85. So that's not good. So I can see that n equals 5 gives me a larger amount than what I want to get. So I'm going to write n equals 4. If n equals 4, then I write 5,600 times 1.02 raised to power 4, and that, when I type it into my calculator, will give me 6,061.62, and that's exactly what I wanted. So that means that n is 4. And that's the final answer. A radioactive substance decays over time. Every year its mass decreases by 14%. How many years will it take for 500 kilograms of the substance to decay to a mass less than 200 kilograms? We start off at 100%. Since the mass decreases by 14%, we have to write subtract 14%. That gives us 86%. And we write it as a decimal, which is 0.86. Then we write the initial amount, 500, and then times it by the multiplier, 0.86, raised to the power of number of years, which is unknown as n, and we want it to be less than 200. It's important to note that in this case, the multiplier is less than 1. So when I start with n equals 5, I would get 500 times 0.86 raised to the power of 5, and that gives me 235.21, which is not good. So I want it to be smaller than that because I want the answer to be less than 200. And the reason that I mentioned about the multiplier being less than 1, which is 0.86, when we raise a number which is less than 1 to a larger power, the answer becomes smaller. So for this reason, in order to get a smaller answer, we have to raise the power of 0.86. So I started with n equals 5. Now I'm going to choose n equals 6 and try that to see what answer I get. So 500 times 0.86 raised to the power 6, that gives me 202.29, still not good. So I would choose n equals 7, and again I write 500 times 0.86 to the power of 7, and that gives me 173.96, and I immediately notice that this is less than 200, so this is good, and that means that the number of years that it will take for the mass to be less than 200 grams will be 7 years. So I would write it takes 7 years. And that's the final answer. This is a slightly different style of question. The question says, calculate the number of years for an investment to double at an interest rate of 10.5% per annum. So we start off at 100%. Then we add the interest rate of 10.5%, which gives us 110.5%, and in decimal that becomes 1.105 for our multiplier. So we would normally write the initial amount times the multiplier raised to the power of number of years. But we don't know what the initial amount is. So we're going to write x for the initial amount, and then times it by the multiplier, 1.105. Number of years we don't know, it's n, but we want the final amount to be double the initial amount. Since the initial amount is x, the final amount, which is going to be double that, is going to be 2x. So we've formed our equation. After forming the equation, we need to solve it. We clearly can see that both sides of the equation have x, so we can divide both sides by x. So that cancels the x's from both sides, and we are left with 1.105 to the power of n on the left equals to 2 on the right. So again, we start with n equals 5 and see how it works. So if n equals 5, then we write 1.105 to the power of 5. Typing it into our calculator will give us 1.65. So you can see that it's not good because we want to get 2. If n is 6, then 1.105 to the power of 6 will give us 1.82, still not good. And if n is 7, then 1.105 to the power of 7 is going to give us 2.01, which is what we want. So we write, of course, this is good. Therefore, it will take 7 years. For the investment to double at an interest rate of 10.5% per annum. So that's the final answer. How do we calculate the rate of interest? Here we're going to put all the information that we've been using so far, like the initial amount, rate of interest, number of years, into a formula. The formula that we want to use is the following. Final amount equals P, which is the initial amount, brackets 1 plus R, which is the interest rate, brackets closed, raised to the power of n, and n is the number of times interest rate is applied, and normally is the number of years. So let's use the formula. Jessie invests £8,000 for n years in a savings account. To find the value V of her investment after n years, she uses the formula V, which is the final amount, is equal to 8,000 times 1.025 raised to power n. Write down the annual rate of interest that Jessie earns. So we compare the formula in the question with the formula for compound interest. The final amount in this case is V. The initial amount is 8,000, which is for P. Then we have 1 in both brackets, and also we have n. So what's left is 0.025, which is going to be, let's choose a lighter color, so 0.025, which is R over 100. So we write 0.025 equals R over 100. Multiplying both sides by 100, will give us 2.5 equals R. So that means that the rate of interest, which is R, is 2.5%. The population of a country increases by X% each year. In 2014, the population of the country was 24 million. 3 years later, the population was 26,996,736. Find X. So, we're going to use the formula for compound interest, which says that the final amount, so the final amount, 26,996,736 is equal to the initial amount, which is 24 million, times 1 plus R, which in this case is X over 100, raised to the power of number of years. So number of years in this case is 3 years. So we need to solve this equation to find the value of X. Immediately we notice that we have to divide both sides by 24 million. So that gives us for the left hand side, we'll get, when you type it into calculator, you'll get 1.124864, and on the right hand side we can see that 24 million will cancel, and we have 1 plus X over 100 raised to the power of 3. At this stage, because we want to solve the equation to find the value of X, we have to get rid of the cubed, the power 3 here. So we need to do the opposite of cubing, which is cube rooting. So we have to cube root on both sides. Cube rooting the left hand side will give us 1.04, and cube rooting the right hand side will cancel the power 3. So we have 1 plus X over 100. We want to solve to find the value of X, so we subtract 1 from both sides. So we'll get 0.04 equals X over 100. And finally, we multiply both sides by 100, and we get 4 equals X. So that means that X is 4%. Or actually, let's write it as a percent. X is 4%. Max invests $6,000 in a savings account for 3 years. The account pays compound interest at a rate of 1.5% per year for the first 2 years. The compound interest rate changes for the third year. At the end of 3 years, there is a total of $6,311.16 in the account. Work out the compound interest rate for the third year and give your answer correct to 1 decimal place. We're going to start off at 100%. And since we are earning 1.5% interest, we add it on. That gives us 101.5%, which in decimal it becomes 1.015, which is our multiplier. Then we write the initial amount, 6,000, times it by the multiplier 1.015 raised to the power of number of years, which is 2 years. And that gives us $6,181.35. This amount is going to be the initial amount at the start of the third year. So for the third year, because we don't have the interest rate, we're going to use the formula. So we write the initial amount for the start of the third year, which is 6,181.35, and times it by 1 plus rate of interest R over 100 raised to the power of number of years. So there's going to be only 1 year, which is the third year. And that gives us the final amount, which the question says is 6,311.16. In order to solve this, we need to divide both sides by 6,181.35. That gives us, so on the left hand side, those two cancel, and we'll get 1 plus R over 100. On the right hand side, when we divide, we'll get 1.021. To solve the equation to find R, we need to subtract 1 from both sides. So we'll get R over 100 equals 0.021. And finally, we multiply both sides by 100, which will give us R equals 2.1%. That's the final answer.